This time we're going to be using the Pythagorean theorem to find the missing leg of a right triangle. Here we have this right triangle, and the first thing that we're going to do is we're going to label our variables, define our variables. So let's call this one A. I'm going to call that side A. We're going to call this side right here B. And then we're going to make this one C. Once again, it doesn't matter which one is A and B. We could have switched those up. B could have been there, A could have been there, but C has to be the hypotenuse, which is there. So now the formula that we're going to use is the Pythagorean theorem, which states that a squared plus b squared equals c squared, meaning if we square both of those legs and add them together, we're going to equal the square of the hypotenuse. Now we know these variables, 5 and 13, so we're going to put them in here. 5 squared plus, we don't know b yet, so we'll just leave that as b squared, equals 13 squared. Now at this point, we should know our perfect squares, and we're trying to get up to 20. So we know 5 squared already, that's 25, plus b squared, we still don't know that yet, equals 13 squared, and 13 squared is 169. So 169. Now, this is looking a lot like a two-step equation, and that's basically what it is right now. We're gonna have to get that 25 over there by the 169 on the other side so we can get that b squared by itself. So what we're gonna do is that we're gonna divide it into two expressions. We're gonna subtract 25 from both sides of our equation. These will cancel out. We're left with b squared equals 144. Now we've got b squared, but we don't wanna know what b squared is, we wanna know what b is. So the way that we do that is take the square root of both sides. Square root, because that's the inverse operation of squaring something. So the square root and the square are gonna cancel out. We're left with b equals the square root of 144, which is 12. Now we're almost done. We've got to check this now. We believe that b is 12, but if that's true, then it should satisfy this equation. We should have a squared plus b squared equals c squared. So 5 squared plus 12 squared should equal to 13 squared. Now that's interesting because those numbers are pretty close. Let's see. 5 squared is 25 plus 12 squared is 144 and 13 squared is 169. We're going to assume you can see that. And 25 plus 144, well, that makes 169. And 169 is equal to 169. So that means that we're correct. 5, 12, 13 is our Pythagorean triple.